use Adam's method of determining apportionment. So first, let's talk through Adam's method, what it is and how do we do it. We first must find the standard divisor and then the standard quota for each state. We'll find the upper quota. So Adam's method uses the upper quota for each state. If life is easy, if the sum of those upper quotas is equal to the number of desired representatives, then you're done. And you're like, woohoo. However, that is not usually the case. So if the total is larger than the number of representatives, we're going to increase the standard divisor. And that's all the information you get. You just have to make it a little bigger. You're going to get a modified divisor and you're going to do it again. So you're going to find a new standard quota, which then gives you a potential new upper quota until the total of the upper quotas equals the desired number of representatives. Let's look at this. So we're going to use Adam's method to determine the appropriate apportionment for a desired 50 representatives. We have 3 states in a given population. So first we have to find the standard divisor by finding the total population, add those 3 together, and then dividing the total population by the number of representatives to give us our standard divisor. Now, once we have our standard divisor, we can find our quota for each state. So for West Daisy, I take the population divided by the standard divisor, and I get a standard quota of 22.963. For North Rose, I get a standard quota of 17.317. And for East Mulch, I get a standard quota of 9.719. So again, you can see we take the population of each state, divide by the standard divisor to get our standard quota. Now again, because in Adam's method here, we are using the upper quota, we take our standard quota, we round up for each one, and we look at what we have. Now, the upper quotas, the sum of those is 51. And this is too many because remember, we only have 50 seats. So we need to increase the standard divisor and try this again. So our standard divisor was 11,147 and 6/10. So let's increase it to 12,000, right? Let's just try that. So when I increase the standard divisor to 12,000, I get new standard quotas, right? Process remains the same. We're just changing the divisor. Well, when I do that, my upper quotas become 20, 17, and 10. But that sum is only 47. That's too low. So I went from being too high to too low, which means I need to pick a number between 11,147.6, right? Our original divisor and our modified divisor of 12,000, because I need to be somewhere between 47 and 51. So let's try 11,500, all right? It's kind of in the middle. So again, I change my divisor and I find my new standard quotas. Well, that gives me upper quotas of 23, 17, and 10, which equals 50. Whoop, whoop. Now you can see this process can be tedious depending on how good of a guesser you are when you're increasing your standard divisor, right, to get your modified divisor. So our quotas here using the Adams method would be 23 for West Daisy, 17 for North Rose, and 10 for East Mulch. If I had still been either above or below 50, I would have had to just continue changing and modifying my divisor until I got the correct total of upper quotas.